Okay, today we will see a new topic called view. Okay, so what is view? View is also on DB object. It's also on database object. Okay, we'll see some notes on that. Very simple topic. See, view is a DB object. It's a virtual table, we say. View is a virtual table. Just go through, write down all this, then I'm going to explain you all this with code only. It is a logical representation of the table in the data in the table. Okay, fine. What is the advantage of view? It helps in providing security. That is, it helps to hide columns having sensitive info in the underlying table. Okay, and it reduces writing complicated join queries, and it reduces data redundancy. Some few points you write it down. Simple it is on one page. Then I'll explain this. Now, view can be classified into two types. One is a simple view, other one is a complex view. So in simple view, what happens? See, view means very common, simple it is. What happens now in a view? You'll be having multiple columns in a table. Okay, so you don't want to expose your full table to whoever is accessing it. So what you'll do, you'll create one view like this. In this view, what you'll do, you'll select whatever columns you want, that you'll select here, and the view will be created. It's a new object now. This table is a separate object, this view is another object. Okay, so in this view, what will happen? Whatever columns you want now, that you'll pick and you'll create a new object. So now whoever is querying now, whatever they are querying, now they'll be querying on what? View. Okay, so means it in fact reflects the data in your table. View is going to reflect the data in your table. So you can do all the CRUD operations on your view. You can do all the CRUD operations, but generally we don't do all the CRUD operations. Why? Because see, a view is used generally for doing read operations, but CUD operation should be done directly on a table itself. If you want to do, see, if you make any changes in the view, it will affect the table. If you make any changes in the table also, it will affect the view. Remember that when you are doing CRUD operation now, any changes in the table will affect the view, and any changes in the view will affect the table. That is why what we do, view should be used only for read purpose, and any CUD operation, create, update, delete operation should be done on table itself directly. This is a concept. So that is simple view. This is complex view. Complex view means you are going multiple tables, you'll pick how many columns you want, you'll create on view now. Okay, so that's all about complex view. So, and I put some points. As I told you, any changes in table will affect the view, and any changes in view also will affect table. Always use view for what? Read operations. Never use view for CUD operations. So always do CUD operations directly on the table. Okay, so I'll show it to you now by creating it. First I'll show you which one? Simple view. Then I show you complex view. See, whatever topics I'm going to teach you today, they are all in one folder. This 14th folder is there, views and synonyms. Open it, view.txt. All the queries are here itself. So I'll copy this. Very simple it is. So what I'll do, I'll create this view in which schema? Ravi Oracle schema. You can type all those queries here. It's very simple. I'll teach you how to write it. Then next I'll open one more object browser. See this, you know. Tables, we know these many tables are there, which we created in yesterday's class. Fine. Now views, are there any views? If I select views, are you seeing any view here? Now when I create it, you can see it. See here, I'm going to create the view. How to create a view? Very simple. You know how to write your select clause now? How you write your select clause? So select your columns. Which column you want? Same, right selector. Okay, from which table I am doing it now? Employee. Just append what? One more extra line on top of it. What? Create view. So create query is used for what? DDL. data definition language. Create view. What is the name you want to give? V underscore employee. V is the prefix, which means it's a view. You can directly say give some other name, but you'll never know the difference between a table and a view. That's why the convention what we follow is for views we have prefix as V. That's it. As so and so. That's it. So now say I'll run this query. You know, understood now? Write the query now. Okay. Create view as, give the name, and see it's like this. Append it. Understood? But I have written it in 2 lines so that it makes you understand very clearly. So I'll run it now. So as soon as I run, see the view is created. You can see the message. So once I do it, see here, refresh, you can see the view here. And in this view, how many columns are there? 3 columns. And you can see the data here. Understood? So now I can do query on this, which one? CRUD operations on this view also. So like example, see this, which is the next query? See, select star from V underscore employee. I'm doing what operation now? Read operation. See, select star from which one? I did it on the view. There are 3 columns, it is displaying now. Understood? It is displaying the 3 columns. Not only select, you can do what? Insert, update, delete on the view. But don't try to do it. View should be used purely for read purpose. Any manipulations you want to do, better directly do it on the table itself. Understood? Don't do CUD operations on view. CUD operation should always be done on the table. I have given it clearly in the documents here. Any changes in the table will affect what? View. And any changes in the table also, vice versa, it will affect. Changes in view will affect table, changes in table will affect view. So always use view for read operation, that's the convention. And never use view for CUD operations. Always CUD operations should be done directly on the table. Clear? Okay. So this is the simple view what I created now. Understood? I took one table and whatever I want, I picked the columns. Whatever columns I wanted, I picked it and created a simple view. And this is the data on it. So this is the data. Clear? Okay. If you want, you can see this is separate. If I delete the view, what will happen? Table doesn't get deleted. See, I can drop the view. Now what gets deleted? Only view is dropped. Table is not dropped. Understood? So it's a separate DB object. Table is different, view is different. Now go and refresh, see the view is not there. Understood? No data found. Okay, now there is no view. Again, if you want, you can create it. See, view created. Now go refresh. You can see the data and the and the view. Clear now? So what is the advantage of a view now? We'll see. Understood? This is how you do a simple view. Next I'll show you how to create complex view. Complex view also very simple, not at all difficult. Write your join query. You know, write your join query. Now, yesterday I taught you. I'm joining which one with what now? I'm joining department with employee. 2 tables I'm joining. Okay. So write your join. After that what you do? Right. Create view V underscore employee underscore department. Means it's a view of 2 tables, employee and department table. That's it. So now run your query. One more view gets created. So now a new view has been created. Let's go. Refresh. You can see one more view. And this is what data now? Means here I have selected in the view only employee ID column, first name column, date of birth column, department name column. See the query how I written. Select employee dot employee ID, employee dot first name, employee dot date of birth, department dot department name. You write your join query. Just append what? Create view. That's it. Understood? So this is a complex view. Understood? So now anybody can do querying on what? If you want, you can do CRUD operations on what? View also. See, I'll do select star from. If you want, you do it. Select star from. I need select. Or you can select your respective columns. V underscore, what is the V implying? V underscore EMP underscore DEPT. Correct now? Now see, I'm right executing the query. Okay, select star from. Okay. Yes. So in the from clause, I told you earlier, For the from clause, you can select what? A table or a view. So this is an example for what now? View. So select is used for selecting columns. From is used for what? From clause. Selecting tables or views. From the view, which column you want to read, you read. I have done star. Whatever columns you want, you do it again. So what is the advantage now? See this. Advantage of a view. It helps in providing security. Yes or no? See it. We'll go back now and see this. It's a DB object, correct? It's a virtual table. Okay. And it's a logical representation of the data in the table, correct? Fine, next. It helps in providing security. That is, it helps to hide columns having sensitive info in the underlying table. Sometimes you don't want to expose the table. Okay. So that time you can provide some kind of a security. You will not allow the table only to be accessed. Means the DBA have this ability. The database administrators they have the ability. You cannot do any CRUD operation on the table. They can secure it. Understood? But they can expose what? The view for you to work. Like that they can do. In that case, that's what is the meaning. It helps in providing security. That is, it helps to hide columns having sensitive info in the underlying table. Next, reduces writing complicated join queries. See, till now you are writing complicated join queries now. On 2 tables, 3 tables, 4 tables. Supposingly in your project it's a common requirement, like you want to write the joins again and again. Instead of that, what you do? Write on view and keep it, and directly start querying on what? View itself. So like this, see, you'll be querying like this now. Instead of writing complicated joins like this, you'll select from the view. Whatever columns you want, you select here. That's it. From v underscore emp underscore dpt. Otherwise, can you do this on a table? No, you have to join both the tables now. So it helps you to reduce writing complicated join queries. That's one more advantage of a view. Third advantage is, it reduces data redundancy. That's it. So like that, many advantages are there of a view. Okay, so you can use it, and it can be classified into 2 types. One is simple view, other one is complex view. Clear? So any changes? Yes, as I told you, either you do the changes in table, it will affect the view, or if you do it in view, it will affect the table. It's directly a mirror. Whatever changes done here and there, it will affect each other. Clear? So that's all about view. Understood? Then the next topic, index. Okay. Index is a DB object. Okay. Index allows the database to find data fast without reading the whole table. You understand the concepts now? So faster searches, and thereby it gives improved performance. Means you'll be having many columns now. You'll be having many type of columns here. You'll be having employee ID. Example, you might have employee name, first name. You might have phone. I'm just putting phone in the same table. Okay, no problem. If you want, you can keep it in the same table or a different table. But phone has been now kept in the same table. So 111, 222, 333, 444, 101, 102, 103, 104. First name A, second name B, third name C, third, like this. Some more columns might be there. So if you want, what you can do now, you can prepare an index on a particular column. Now why you prepare the index means, say, you know what is indexing now? In books, when you read now, in the last, if you want to search any topic, instead of searching full book, what you do, you go to the last and check for index. In the index, everything will be arranged in alphabetical order. So because of the index, you can search anything faster. That's it. So same way here, what happens, you can index any column you want. Okay. Once you index the column, now what happens? The data in that column will be internally. Okay. One list will be created now. One separate list will be created. Okay. Where the same data will be replicated, and it will be arranged in what? Alphabetical order. Okay, here while storing, I am keeping it in alphabetical order. But generally what happens, data will not be stored in alphabetical order or sorted order. So all this data will be picked and stored into what? Some sorted order like this. Alphabetical order or something like this. It will be stored. So now if you query on this column now, if I say select employee, first name, select first name and employee ID where phone number is equal to 111. So that time it will refer to this index and search will happen faster. That's all. So you'll write the same query, select what? Whatever columns you want from the table name where phone is equal to so and so. So automatically the search, otherwise till now what was happening now, when you write a query like that, it was going linearly, every column it will go and check. But now what will happen, it will use this index. Because it uses this index, it know where phone number means, where phone number is equal to 567 means something like that, it will go to the phone numbers where it is starting with 5. Or if it is alphabetical order, it will go to that particular location and start doing the search. So that is how it enhances the performance, nothing about this more. Understood? So index will be created only on okay, and index should be created on columns where a lot of read operations are happening. You should not create index on columns where a lot of CUD operations are happening, because you see it is enhancing the performance, we know. But if you go on creating the indexes, now what will happen? Every time you do CUD operation, the list has to get altered here now. One separate list has been created. This is table, this table is different. This is a different table. Internally on list has been created, it should be used by what? Oracle. So always it will be referring to this list and searching now. So now if you start doing too many CUD operation, because you'll insert, you'll update, delete, means what will happen? The data goes on getting manipulated. That's why you should not create index on columns where a lot of CUD operations are happening. Understood? So see, generally you should not do it. You always create a index on a column where a lot of read operations are happening. Like example is phone number. In phone number, generally manipulations will not happen. You'll never insert, update, many times you'll not do it. So that's why an example I gave you. So that's it. See, advantage of index is faster searches and thereby it gives improved performance. Indexes should be created only on columns where a lot of read operations are happening. I'll create it and show it to you. Just see this. And okay, we'll finish this. But never create index for columns where a lot of CUD operations are happening. When a primary key or unique key is added on a column, that column is indexed implicitly. For primary key and unique key, you don't have to create the index because it is indexed implicitly. Okay, for creating index on these two type of columns, it will give error. Any column apart from primary key and unique key needs to be indexed explicitly. The users cannot see the index. It is just used to speed up searches and queries. That's it. Nothing more about index. So I'll just show you how to do it. A simple query, say index.txt. So you know our phone table is there now. I'll create the index on what? The phone table. See, index is also on DB object. So I'll be creating this index in which schema now? I'll be creating this index in Ravi Oracle schema. First, okay, if it is there, it will drop. It's right now not there. It will give error. Fine. Now I'll create one. See how I'm creating? Create index. Create is used for DDL queries. Index. What is the name I'm giving? IDX underscore phone. IDX underscore phone on which table? Phone table. In that which column? Phone underscore number. Like this you can do now. So once you do it, the index gets created. See it, index created. Now you can go to the object browser and check here. Indexes. See, earlier 6 indexes were there. Which one? We have 6 primary keys now. On which table? Primary key, department, email. So they are there. All primary keys are what? By default implicitly indexed. But a new index has got created now. Called as what? Phone. So see this. But it will not contain any data and all that. Internally it has generated on separate list. It's on separate DB object now. It has taken all the phone numbers from phone table and on separate list has been created now. Whenever you do querying now, internally it will be used now. So we cannot see the index. It only is used internally. If you want, create the index. Understood now? That's all about index. Nothing more in index. It's just used for what? See, it's a DB object. Correct? It allows the database to find data fast. It faster advantage is faster searches and thereby it gives improved performance. Nothing else. Now whatever you query now, supposing I'll write a query, select something like this. Now that index will be used internally. You know how to write the query now, write it. Select something like that. Understood? Means you have to join 2 tables now, employee and phone. So that time where phone number is equal to 222. Yesterday's query only. Same query you write. Okay, given a phone number, select the employee details. Same query, but this time it will be much faster. That's it. Because you have used an index. Clear now? Okay. So that's all about index. So I have clearly mentioned it. The users cannot see the index. It is just used to speed up searches and queries. Nothing else on this. Yeah? Fine. So we'll move to the next topic now. Synonym. So synonym is also one more what? DB object. Synonym is also one more DB object. Synonyms are nothing but alternate names. Understood? Synonyms are nothing but alternate names. Like you have got many examples now for synonym. Any example? English synonym. English synonyms, you know, no. Antonyms means opposite. Synonym means same thing here. Okay. Synonym is a DB object. Dual. We have worked on the dual table. It is one of the example for what? Synonym. It's nothing but a table only. Okay. See this. Dual is a synonym for a table. I show you how to create our own synonym. But first understand this point. Synonym is a DB object. It is one of the examples for synonym. Dual is a synonym for a table. See, dual is a table with a single row and single column with the name dummy. So dual is a table actually. It is a table with a single row and single column called as dummy. Okay. Now this table is where, you know, in system schema. You know system schema, now the administrator, it is present there. Now system schema has granted permission to access this dual table in any other schema. System schema has granted, understood? See, system has granted permission to access this table dual which is present in system schema to all users of schema. That is why when I was querying in Ravi Oracle schema. I said select something from dual. It was working. Understood? Because system has granted permission. Okay. See, system has granted permission. Yeah, we saw this. See how it has granted permission? See, actually the dual table is in system schema. Okay. It is granting permission to what? Ravi Oracle. Means not only Ravi Oracle, any schema can access it. Okay. See, actually when you are accessing any DB object in another schema, no? If you want to access, permission you will grant. But if you are not giving a alternate name, then you have to use full name like this. You have to use the fully qualified name, we say. Fully qualified names means what? Select from star from system dot dual, you have to access like this. But we are not doing it like that. How did you say? Select star from dual. Why? Because we don't want to use this fully qualified class, fully qualified name. Fully qualified name here means what? Schema name dot table name. Like this, that you have to write the query. So this is the actual way you have to access the table in another schema apart from system. But we do it like this. How did you do? Select star from dual. You did it like this. So synonym is actually created to avoid full schema name in another schema to access a DB object. Okay. A synonym is an alternative name for objects such as tables, views, sequence. For anything you can give an alternate name. For any DB object you can give a alternate name. I'll show you one, you'll understand. I'll create a synonym now. You'll automatically understand. See, it's very simple. See, this is the concept here. So, you know, we have got a table called as what? Employee. You have got data inside it. What is the data? 101. If it's not visible, just manage. A, B, C, same table. Your employee table is where actually you created now. Where it is? In Ravi Oracle. If I want to work with this table, where should I go now? I should go to Ravi Oracle schema only. Is there any other means? Can I go to Scott schema and work on this? No. Means where your table is present, only there you have to go and work, because the default permission given to you is you have to work with the table only in the same schema. Permission given to default. Okay. But if I want, I can give permissions to work with that table in what? Another schema also. We can give permission. So how will you give the permission? System has to give the permission. System will give permission now. But once it gives the permission, here you know how you have to write your query. You can access it now. Once it default, it is not allowed. After granting permission, it will be allowed. So here you can write how? Select star from, you have to write Ravi Oracle dot schema name dot table name. What is the table name? Employee. So every time writing your query like this becomes complicated. So that is why what I'll do, I'll create a synonym. After creating the synonym, example, the synonym name will be employee underscore syn. This is one DB object. I'll create it. Alternate name for what? This one would be this. That's it. And now this time I'll write the query as what? Select star from. That's it. Simple concept. Understand concepts. Doing it is all simple. Understood? So this is a concept. So means a table present in one schema cannot be accessed in another schema by default first. Okay. If you want, you can give permission. Once you give the permission, you can access it. Okay. But how do you access it? By using full qualified names. Fully qualified names means schema name dot table name. Okay. So but if you don't want to do that, you can create a synonym and use like this. Okay. So now see, always a table in the current schema you can work directly. How? Select star from employee. But a table in another schema, if you want to access in another schema, you have to go with schema name dot table name. To avoid that, we create synonyms. Simple. So I got steps here. I give you steps. Just see, this is the concept what I am doing now. Already employee table is there. We are already having it. So I'll create one synonym for it. Just see how it happens. I've given you clear steps here. 5 steps are there. If you follow it, automatically all will happen. See, what you have to do, first step, see this. First step is, okay, these are the just 5 steps you follow, automatically it will happen. And I've written the queries here also. See, create a table employee in the schema Ravi Oracle. It's already there, yes or no? In Ravi Oracle, see, this is Ravi Oracle schema, see there. Ravi Oracle schema, if you go to tables, there's already a table called as what? Employee. Data also is there, yes or no? Clear? Now if I want to work with this table, I have to be in what? Ravi Oracle schema only. I cannot access this table in another schema. So fine. So I want to do it now. I want to use this table in what? Scott schema. That's my requirement now. See what I'll do. So for doing that, I have to log into what? System schema. Look at the second point. First point is over. Table you have already created. Second point now. You have to log into system schema and grant permission to what? Scott to access the table employee present in Ravi Oracle. So I have to log into what now? And execute this query. Just copy paste this query. Nothing you have to do. See this. You have to log in as. I'll close this. So I have to log in now. Log out and I log in into what? System you log in. Password is what? Cluster. Yes, here you execute your query. In the system, see, I'm in system schema. Can you see that on top? I'm in system. So system is the administrator. He can give the permission. So he'll give. How he'll give? Say grant. So these are DCL queries. DCL means what? Data control language. These are DCL queries. So this is an example for DCL what we are saying now. So grant. We have seen all the queries now. DML, DCL, DRL. Okay. TCL is the transaction control language that we don't learn. It will be learned by LSQL developers. Yeah. See, grant. You are granting the permission for what operations? For selecting, insert operations, update operations, and delete operations on which table? Carefully see. Ravi Oracle dot employee to Scott. Very clear it is. So system will grant the permissions to only Scott. If you want, you can grant permission to other schemas also. Just I'm showing you for Scott. So like this, see now, I'll run the query. You'll get it. Statement processed. Okay. And it has executed. Now permission has been granted. So now we'll log out now. From which one? System. So the second step is over. Second step is over. What is the second step? Log into system schema and grant permission to Scott to access the table employee present in Oracle. Fine. Now what will I do? You want to work with the table. So I have to log in as what? Scott. So I log in. See a third step now. Okay. Third step. So I log in into Scott now. Yes, we are here. Now Yeah. Now we'll try to run this query. Which query? Select star from employee. Where? In Scott I am telling. Scott schema I am telling this. See, this is Scott schema. It will tell what? Select star from employee. It is not there. So you get an error. Table or view does not exist. Table means there is nothing like name. It is searching in the current schema. Understood? So it will not work. Okay, but you want to access it now. Yes, you can access, but how will you do? Yes, full name like this. Now it will work. Same, only what I will do now? See this. This will not work. But if I do this, 100% it will work. No, now it will get it from, because system has granted permission. Done. I am doing star. Understood? So it will select all the records from employee table. Fine. But every time I want to work now, selecting is okay. If you want to insert, update, you have to use what? Full name like this now. Schema name, dot, table name, schema name, it becomes very complicated. So that's why we'll go with the fourth step. We'll create the synonym. How will you create? See, the fourth step is very simple. What? Create or replace synonym. That's it. If the means if the synonym is there, replace it. So in the Scott schema only, I'll do it. So why is the Scott doing like this? Because he doesn't want to use full names. So he'll create of one schema now. After he creates it, synonym created. So now you can work. How? What is the name I have given? See here. Create or replace public synonym. That's the syntax. What is the name? Employee underscore syn is the name I have given. Okay, for what? Ravi Oracle dot employee. That's it. So once I do it, so I should write the query now as what? Select star from underscore syn. That is the name. Run the query. I don't have to use the full name now. That's all about synonym. Understood? So synonyms can be created for any DB object, not only tables. You can create a synonym for what? View, anything. Stored procedures, so many things are there. So many DB objects are there. For all that you can create. I just showed you how to create a synonym for tables. Almost all processes same. There is no difference. So just follow these 5 steps. I written it very clearly for you. You don't have to type anything. Okay, I have given step by step very clearly. Table is only thing is table is already present. The table is already present in Ravi Oracle schema. That time trying to access in Scott schema. Yeah. So you completed 3 topics today. Which one? View, index, synonym. Understood? Okay, that's it.